When we conduct a simple regression analysis, we are interested in exploring and quantifying the relationship between two variables. To examine a correlation, we need to have data from two continuous variables. For example, we might be interested in the relationship between consumption of candy and number of fillings. Let's say we have 15 data points. Already you can probably see a pattern in this data. It looks like something's going on. But how can we quantify this relationship? This is where our R's come in. R is our Pearson correlation coefficient. It provides information about the magnitude and direction of the relationship between our two variables. This value varies between 0 and 1 and can be positive or negative in valence. The value of the coefficient tells us the strength of the relationship. 0.1 to 0.3 is weak. 0.3 to 0.5 is moderate, and greater than 0.5 is a strong magnitude relationship. A positive sign tells us that as one variable increases, so too does the other variable, like our candy and fillings. While a negative sign indicates that as one variable increases, the other decreases. So for example, as exercise increases, body weight decreases. So if our correlation coefficient here is 0.53, it tells us that there is a strong positive relationship between quantity of candy consumed and number of fillings. The other R we can interpret is R squared, which is, quite simply, the value of R squared, otherwise known as the coefficient of determination. This value can vary from 0 to 1 and may be expressed as a percentage. So if our R squared value is 0.28, that tells us that 28% of the variability in number of fillings can be associated with candy consumption scores. This leaves 72% of variation that could be attributed to other factors, such as other sugary food and drink, brushing and flossing, or regular visits to the dentist. One last value to consider is our intercept or constant. This is the value of Y, or number of fillings, when X, or in this case candy consumption, equals 0. So let's draw an imaginary line of best fit. So if our intercept is 1, it would tell us that you would expect a person who consumes no candy to have 1 filling. Just to recap, our R tells us about the direction and magnitude of the relationship. R squared helps us examine the proportion of variability explained. And the intercept tells us the value of Y when X equals 0.